In the final lesson, we will talk about trying to identify the behavior of a particular piece of malware. And what we'll do is that we will end up running the malware within our virtual machine, making sure that our virtual machine has a host-only based system so that the malware can connect out to the internet. And then we will use some of the Linux command line utilities to see what happens to the state of the system as the malware is running. And so if we can't find out specifically what the malware is and does based upon our static analysis, at least we can see how it behaves in a dynamic analysis to see what it's doing and perhaps even why it's doing it within our running virtual machine. So I'm going to do this a little differently. We're assuming that I found the CN program, or netcat misspelled, on another system, and I put it on a USB thumb drive. I've used the static analysis procedures that we saw previously, and so we're doing this from a fresh VM that we've created. One of the reasons you might want to use a fresh VM is to make sure that you use an untainted system and one that you know the settings. And for example, you could have already captured the MAC times for all the different files for a standard installation, and then you can compare those files to the file system after you run your suspected malware in order to determine any differences in the files located on the virtual machine. So what we'll see is that we no longer have our netcat running, because I'm assuming we'll have copied this to a brand new system. Notice it's not running on here. And we're also assuming that the static analysis didn't provide us with any information about the behavior or what the executable suspected malware actually does. So we're just running this from a point of no previous knowledge. And so we've copied this file over, captured _exe, and we want to make sure in our VM, our settings, that we're on a custom host specific virtual network, host only. So let's go back and look at our file, and let's get a long listing. And you notice the access control permissions over here. This is an executable, but it has no executable bit set, so we're going to need to change that. And so let's make this 755, which means it has fully executable permissions. In fact, let's just make that 744. Oops, 744, which means the owner should be able to run this, and the owner is me. And capture exe. Let's take a look at it and make sure. Now it has the execute bit set for the owner. And so now let's go ahead and let's try to run this. Okay, that provides us some information right there. Now obviously, if we're saying, well, there was no information in the executable that would help us with identifying the program, then obviously this wouldn't be showing up. So anyway, this is again just an illustration. So let's go ahead and we'll run this. Let's run this as sudo. And it says on here to run this as. So let's go ahead and run this for listening on 2222. And since we're doing this, and I wish I hadn't started out with server, I wish I had run this in a. And I wish I had run this as in Mint, because it would be a lot more obvious what I'm doing here. And I can open up another pseudo terminal, but I can't. So recall that we were running this on TTY1, the primary terminal. There's 6 other terminals available to us, 2 through 7. And so what we can do to run the commands, because I don't want to run this in the background, I want to run this in the foreground, we can go ahead and hit enter. Notice we don't get the prompt back, so essentially what it's doing is it's waiting for information. It's listening over port 2222. We can bring up the other terminal by holding down the Alt key and hitting one of the F keys from 1 through 7. Not F1 because that's what we're running on right now, but F2 brings up another terminal. We can log in. And now what we can do is we can go back, and as we've previously run, to look at the processes. We see that only a single process is created, malicious file. You run netstat tupan less. You can see that it is listening on TCP, and you can go down and see if it's also listening over UDP, and it doesn't appear to be. And so now what we can do is to get down to the use of LSOF is a list of open files. And this is a command that shows the files that are currently open and being used by the running processes or applications. So we'll find out with Netcat, or well, actually we don't know it's Netcat, I guess, but the fact that what files are open by Netcat. And one of the things you can do is to see pre and post is to run LSOF beforehand, output the results, and then run it after you run your suspected malware, and then compare the two. So let's take a look at LSOF. So we're going to run LSOF, and we just simply need to run this. In fact, let's run sudo LSOF, and let's output the results to evidence, and we'll call this captured exe.lsof. Okay, now we can go, and with less, just to look at, whoops, let's go to the evidence drive, the evidence directory, and look at the LSOF file. So what this is telling you is the commands that are ordered by the process identification number. Notice in it right here. And so we can scroll down, and actually, I'm sorry, let's get out of this and let's go back and look at the process ID number 28956. So when we run LSOF, and we want to run this with, whoops, we want to run LSOF-N so it doesn't look at the, it doesn't use DNS to resolve any IP addresses. And now we can rerun this. With less, whoops, and it says permission denied. We can run this as like I did before with sudo. And now we can scroll down, and what we want to look for is 28956. And so now we have the information for the open files on captured_exe, who owns it, what type of file it is, right here. Notice that we have IPv4 here, and it's listening on 2222. And let me see if it opened any other files. You notice, oh, also notice that it gives us the full path name of the file in this line right here, and it tells us the shared libraries that are used. So you have 1, 2, 3, and 4 shared libraries. So obviously this has been compiled dynamically, which means that in order for captured_exe to run with, you know, Netcat, that it needs these libraries. If it had been compile statically, then the information from the shared libraries would have been compiled into the executable, and then they would not need these shared libraries, but it needs those. You can see where it's running from, and unfortunately it didn't open any files. And so this provided us no clear information than what we saw before. No additional information than what we saw previously. And okay, finally we can use a program called strace. And this is a command that's included with Linux that acts kind of like a wiretap between a program and the operating system, and it will display information about files or networks that are accessed, memory access, and other types of systems calls. And the way we want to run this is using strace-o, and which indicates that the trace should be written to the file, whatever the file you're running. Notice here, so output here, and then this is the file you're running. So what we're going to have to do is to go back and stop the execution of the file by killing the process and then rerunning the file. And so let's clear the screen, and let's do man strace. It traces systems calls and signals. Notice the -o for file here. And so we can type sudo strace-o, and we want to call this captured exe.out. Oh, first we need to do what? We need to kill that process. 28956. And now we can go back and run. Let me clear this. Sudo strace and -o, and the file to write out, captured exe.out, and then we run captured.exe. And as you recall, it wouldn't work in that fashion, so we have to go back and let's run listen 2222. And it should have written that out. Now we can hit Control-C to stop it. Let's take a look. We see we have a captured _exe.out. Let's take a look at that less. And so this gets very complicated, but what you see is there's a call to execute captured exe with the parameters -l and 2222. So this gets complicated, but what we're really looking for is the opening of any files to write to or to read from, as well as opening any sockets or child processes, which actually should have shown up in the ps command. But you see here it is trying to access a file ld.so.no hardware cap, indicating there's no such file or directory, but apparently it's able to work without that. And we can scroll down and see, I'm just trying to find interesting stuff, because a lot of this so one of the things you want to look for is the word open, and what that does is that indicates that it's opening a file for reading. Okay, I went through and I did the dynamic analysis on our captured _exe, that is our netcat file, and it was very uninteresting because it really wasn't doing anything. It wasn't really, for example, writing out to any files or reading any files. So what I've done is, let's change this up a little bit for the dynamic analysis so I can show you some of the more interesting things that we can identify with respect to reading and writing files. And that is with this new file that has been sent to me, and it is called PMUD PCT. And so you might be able to guess what that is if you read it backwards. So it's TCP dump, which is a a file packet capture utility that, along with the Berkeley Library packet capture, allows us to read a raw socket, open a raw socket, and read everything that's going over the network. And so this should be a little more interesting than netcat. And so, for example, if we run sudo npmud, I'll show you what this does. You know, essentially what it's doing is it will read all the network activity. And there we go. That was a little slow, but it reads all the incoming and outgoing packets right in here. And so let's stop that with the Control C. And what we can do is let's go back and pretend we're starting all over again. And what we'll do is first we're going to run this off a clean machine, that is a new virtual machine, and we're going to run TCP dump from our first terminal. Whoops. We want to run this, and then we can switch over to another terminal using F2. And then we can run psaux grep and pmud, and we can see it's running as root, and this tells us the process ID, which is 29305. And if we run netstat from here, let's just run this with an AN. See, this gives us a little more comprehensive information. This tells us all the TCP and UDP devices, and then if we scroll down here, you'll notice that the TCP dump is not showing up in netstat, although it is showing up in the PS command, and the reason is that it's opening a raw socket, and therefore it won't show up under the netstat command. But if we want to see what else it does, is that we can use the LSOF command, which stands for list open files. And so it will show all the list of open files. It will show all the processes, as well as any of the open files or pipes or network sockets that have been created by that file. So let's make sure that this is still running over here. It's still running. You type Alt F1 to get back there, Alt F2 to get back over here, and now we can type sudo lsof and greater than pmud lsof to see all the open files. And let's take a look at that, and you see the list of open files. It's sorted by the process identification number, so init is always the first. It's the user who owns the process, and then you have field display with the current working directory, memory usage, and you have the type of file, and so on. And if we go down and we search for 29305, we'll see this is where it first shows up. Right here. So it shows the directory. Notice it says current working directory, so it shows us where it started from. And we can see that it's got a number of different libraries that are being used, and which means that the TCP dump was compiled dynamically to use dynamically linked libraries. And if we keep on moving down, we can see all the library it used, and we can see the terminal from which it was accessed, TTY1. Notice here at the end something very important, that it opened a raw socket right here, indicating the possible presence of a sniffer. Let's get out of here. And then the last thing we want to talk about is strace. And strace acts like a wiretap between a program and the operating system, and the output is quite complex, but it's good to at least be familiar with it and try to understand what it does. And I don't understand everything. And displays information about files or networks that are accessed, memory access, and other types of systems calls. And we run this with strace, and we need to run that as sudo, as root. -o is the file output, so we want to write out -o to a file, and then we want to run the command. And as I said, this gets quite complex, so let's go back over here, and we'll need to go back to Alt F1 and stop this process. And now what we can do, clear the screen and run strace-o pmud.strace, and then run the actual command. Let's go back over to our other terminal. Let's clear the results of LSOF. And now let's look at the output for strace. And so as I said, it's quite complex. And some of the things you need to understand, the first thing it does is it's a call to execute the file with no command argument, so that's what we see here. It attempts to access a shared library. Right here it says there's no such file or directory, but it's still run. Notice that it opens, it opens a shared library right here, the preload file. It accesses that, opens it read-only, and it opens the library, the crypto library, read-only, and it reads information from that file. And notice also that it will say when it closes a file, close 3, so it opens this file, then it assigns a file number to the open file, and when you see it close, that means that it's closing that file because it's read the necessary information. Once again, it opens up a couple of library files, lab pcap, which is a required shared library to run TCP dump. It's a packet capture library, and notice that it assigns it as the number 3, and then it read 3, and then it reads information from that file, and notice that again it closes that file. Then it reads the C library here, opens, and it assigns it the file number 3, and it reads from that file. And it does this for a few more files. Please bear with me because it gets interesting down here. You'll see that it opens up a socket here. Notice it says raw socket underscore raw, and all a raw socket is it's a socket that allows the direct sending and receiving of network packets by applications, and it bypasses all the encapsulation in the network's software of the operating system. So raw sockets receive packets inclusive of the header, as opposed to standard sockets which receive just the packet payload without the headers. And so as you will see shortly, is that we will see some of the headers down here that are being written to standard out. It's good to see, or at least be familiar with, how the operating system works and what the open and close mean. So see you here, it opens socket datagram, socket underscore dgram. It assigns that to number 4, and then it reads this in for the interface name each 0 with the IP address this, which is the IP address of our system right here. Okay, so we get down to this section and it says write to, and so 2 is going to be standard out in this case. This is PMUD PCT verbose output suppress, listening on ETH0. That's what we saw that was being written out to standard out. And then it's polling the raw socket. Notice that it's not finding anything, and it's saying it's timing out. And that's essentially what we saw when we first ran it, is that we started it and then nothing was being shown on the screen. Oh, and that was all that was written. Shoot. Okay. So anyway, if you run this yourself, if you run this again, in fact, let me run that quickly again and we'll take another look at it, because in the one I ran previously, there was actually some information that was written down in terms of IP addresses and so on. So hold on a second. Here we go. Okay. So while we ran this, notice it's polling. If you go back and look at the file descriptor, if you go back and look at the file descriptor 4 up above, it should say that that was the raw socket. And notice it's writing now to 1. That's the file descriptor 1. It's writing the time, the IP address, and so on. And so that it shows you it's opened a file and it's writing to it. And of course, in this case, it's going to be standard out, which is the screen. So this is essentially what it's writing to here. Okay, I know those examples are a bit complex. This is meant to familiarize yourself with the process. This is all a learning process. That's a lot to take in at one time. If you take this step by step and do some of these examples, take some simple programs and open them up and run strace, LSOF on them and try to read the information in them. You'll find it very interesting and illuminating, and it'll help you better understand how to work these in an incident response setting.